Hello, today we're going to start Chapter 9. We'll do this in two lectures. The first lectures will cover translations, rotations, reflections, and symmetry. The second lecture will cover similar figures. All right, and we'll cut out and use different things out of our notes, out of our handouts. Just a basic idea of what this chapter is about. And the way I do this in class is I tell my students to stand up and take a step. So imagine that this is a person standing. Take a step. You have now done a translation. Okay. Turn around. You have now done a rotation. Imagine that you're standing in front of a mirror. You're seeing a reflection of the item. So if I look at this as a mirror, my hand is a mirror. When I reflect this about a mirror, everything's opposite. And then symmetry shows that if I draw if I have my pen, if I have a pen that is uniform, that is the same, and I draw a line down the middle, imagine cutting it in half, then what's on one side is the same as what's on the other. And so that's the basics of what we're doing. A translation involves moving an object in a straight line and not turning it. A translation is a transformation on a plane determined by moving each point of the figure the same distance in the same direction. So you need to know certain definitions, and those are on your vocabulary list. So if I translate my hand, so this is my pre-image, and I translate my hand over here, this is my image. And you're not getting a good picture because I don't have it zoomed down enough. So here's my hand. If I translate it to over here, this is my pre-image, this is my image. This is the object, this is the image. We have ways to translate. We can talk about moving stuff north, south, east, and west. We can talk about ordered pairs, or we can use vectors. Reflection is copying a figure across a line. So if I have trying to see what I can grab that I have two of the same of. So if I have that this is a line and I have a pen and I copy it and I reflect it, so if it's that direction here, then it's going to be opposite when I reflect it across a line, right? Think about a mirror, about a reflection in a mirror. If you're standing facing a mirror and you raise your right hand in the mirror, it looks like it's your left hand that goes up. The line is the line of reflection. A rotation would be taking this and rotating it about a point. That's rotating at 180 degrees. If I start here and I rotate it, that's 180 degrees. Rotation. These are all transformations. All transformations are congruent. If I put this where you can see me, see the stuff, you can't read the writing. I'm going to assume that you all have the notes. A glide reflection, there are different types of reflections, translations. A glide reflection is a translation followed by a reflection. So imagine if I take a step and then this one, remember that if I look at my hands I got to get this far enough back that you can see. So if I look at my hands, they are reflections of each other with the line being down the center, right? So a glide reflection would be a step up and then it's reflected. Everything in reflections, everything is congruent. They're all known as congruent transformations. The second section, so that's 9.1. 9.2 is symmetry and tessellations. Symmetry just talks about, now there's a difference between a line of reflection and a line of symmetry. If I look at this figure right here, and I fold this in half diagonally, right? So I'm folding this in half diagonally. And you notice that I get the same thing on each side. This line that goes across the diagonals is a line of symmetry. Okay? A reflection is that I take this whole figure and I reflect it about a line. So that's the difference. A reflection moves it. A line of symmetry is within the one object. I have different types of symmetry. I have vertical line, horizontal line, diagonal line. I have point symmetry. I have reflections, rotations, and you can't see all of these that I'm pointing to. You should all have the notes. Just kind of read through these definitions and make sure you understand them. So now, and these two sections have the homework together. So now let's start talking about the homework. Now let's go through this. So notice that I want to translate the figure down the vector. So this would be moving at a vector. So I'm going to go down 3 and I'm going to go right 1. So I'm going to move this point right here down 3, 1, 2, 3, and over 1. So right here is now L prime. So this is going to go down, P is going to go down 3, 1, 2, 3, and over 1. So here is P prime. M 1, 2, 3 over 1. I 1, 2, 3 over 1. S 1, 2, 3 over 1. E 1, 2, 3 over 1. Now, you notice that when I reflected, okay, we're going to have to go back and redo this. Because you could not see that other than the fact that it's too far away. Alright, so what I did is here's L prime. Notice I go down 3 and over 1. So from L prime I go 1, 2, 3 over 1. From P, 1, 2, 3 over 1. M, 1, 2, 3 over 1. I, 1, 2, 3 over 1. S 1, 2, 3 over 1. E 1, 2, 3 over 1. Now, I did that by moving each point, right? Now, I could just as easily have taken and moved L and then done everything in respect to L. And that's how I'll do the next one so that you can see a different method. Sorry about that. That is the alarm to go pick up my kids. I knew it was going to go off. I thought by putting my phone on sleep it would not, but that didn't work. So I could move L and then say that P is back 3 from L. And then M is across a diagonal, and I is across a diagonal. And to get from I to S, I go down 2 and in 1. So I could do it once I move one point, I can do the others in relation, or I can move each point. It's up to you. Now, for example number 2, it says to reflect this across the line. So what I'm going to do is I'm going to use this point right here as a point P. I'm going to label these as A, B, C, and D. And so I'm going to use point P. Now, C is 1, 2, 3 up from P. And so now, if I'm reflecting it, it's going to go out this direction. 1, 2, 3. So that is C prime. Remember, it's not going to go down. It's going to go, sorry. So C is up 3. If I reflect it, it's going to go this direction, not straight down, right? Another way to do this is to use a mirror to look at the image in the mirror. Now this is going to be a little harder to see. So if I have this mirror and I want to look, and I put the mirror on the line and I look inside the mirror, you can tell that the figure is going that way, not this way. Not this way. It's going that way. Okay? And so you could actually use a mirror to do this. Another thing that works is if you have a good phone, you notice that you can barely see it in the phone right here, and that you can use your phone as your mirror. So there's C. Now to get to D from C, I go 1, 2, and over 1. So I'm going to go 1, 2, and up 1. And then to get to B, I go down 1. And then for A, so this is A prime, this is B prime, and this is D prime. Okay, so that would be reflecting it about the line. To reflect this about the line, now since this line is horizontal, when I reflect it, my x values are going to stay the same. So C prime is going to come 2 down off that horizontal line, and so D prime is going to come 2 down. 2 gets me to the line, and then I go 1, 2, 3 more to find A prime. And B prime is 2 down from C. Okay. So determine the coefficients. So A prime is going to be 4, -1. B prime is going to be 2, 0. C prime is going to be 2, 2. And D prime is 6, 2. Now, the x values stay the same, the y values change. And why is that? And that is because R is horizontal. All right. Consider the parallelogram whose diagonals are m. Describe the transformation that would map ST, so ST, to RU. Just in case you're wondering why I'm not doing this, is because I'm looking for some paper for some pens. These are the Sharpie pens, and this is transparency paper, so future reference. If I write on this in Sharpie, then I use alcohol, I can clean it. So this is ST, and I want to map it to RU. So how do I get there? Well, if I rotate it, if I reflect it, so if I reflect it, then notice it's not quite there. If I rotate it 180 degrees about M, so I'm just putting my finger down on M. If I rotate it about M 180 degrees, then it translates down to RU. All right, and the same works for the to find the angle SRU and RST. If we reflect UM across hold on. If I reflect UM, so I'm going to reflect it across this line, then I get this one. So if I reflect it across the line, then what I get is the black. Is that true or not? No, it's not. Think about it. So if I reflect this across that line, what happens? Notice that my line goes up. Can y'all see that? My line would go up. So if I reflect UM, okay, so I've reflected it about the line, so the line stays the same. Hold on. Okay, we'll try again. So here is the line I'm going to reflect it about. Okay. So that line is going to stay on top of itself, and this is the line segment I'm trying to reflect. I'm doing part C. So here's the line. That line stays the same. Notice what happened to the red. It almost goes 90 degrees up from the picture. So if I reflect it across M, if I reflect this line across UM, then no, I do not get TM. I get a line that goes almost vertically. Now, when would I get that? Only if it's a square. Look at the following figures. Describe any translations, reflections, rotations, and glide reflections that will move part of the figure on top of another part of the figure. Supply the vectors or other means of communicating the translation. Okay. Now what I did is I took and I made these figures a little bigger so that possibly it might be a little easier to see. The first thing, if we look at the figure as a rhombus, so if we look at each of these, so here's a rhombus, right? And here's a rhombus. Now, to get from here to here, notice, so that's the red one. If I reflect it, I get the same thing. So if I reflect this across this line, then I'm getting the same rhombus. Similarly, if I take my original rhombus and I reflect it across this line, then notice I get the same thing. Okay. You can also say that if I take this rhombus and I rotate it, (120 degrees, then I get it. Or it can be mapped as, next. If I look at these as hexagons, right? This is a hexagon. 1, 2, 3, 4, 5, 6 sides. Then that's also a rotation. Okay. So there's that figure. What about the next figure? The next one on our sheet is this one. Okay. The top row can be translated to the second row. So this top row becomes this row. It becomes a reflection about the line across the middle here. All right, if I draw a line, there, that could be a line of symmetry. I also have another line here. I also have the diagonals. These are also lines of reflection. That one didn't show up. My ruler, this is one of my older rulers, so it has little gash marks in it. The first row can be rotated 90 degrees and get me the side row. So if I rotate it 90 degrees counterclockwise, I get this row. So if I take this top row, rotate it 90 degrees, I get this row. If I rotate it clockwise, I get this row. Counterclockwise is one row. Okay, and there are several different things that I can do. I've named in the notes, I've named 3. Some of them I've named here are the same. Some of them are a little different. So that's that figure. Now let's look at the third figure on the page. And again, I blew all of these up just because I thought that they would be easier to see if you could see a bigger one than just what's on the page. It can be rotated. If I take this picture and I rotate it 90 degrees, I still have this picture. If I rotate it 120 degrees, I still have this picture. If I rotate it 210, that's 90 plus 90 plus 90. Isn't that right? 180 plus 90 is 370. So if I do 210, I still get the same thing. I'm not sure about that number. There are horizontal and vertical lines of diagonal. So if this is a line of reflection, I have a line of reflection vertically. I have line of reflection diagonally. These are also line of symmetries because they're symmetric about these lines. In that respect, they're the same. Okay, so those are lines of symmetry or reflection. They're both the same for this in this case. All right, now let's look at the clocks. Okay. If I have, if we reflect the angle formed by the clock's hands at 3 o'clock, so let's draw 3 o'clock in. What is 3 o'clock? We have the long hand on the hour and the short hand on the 3. So there's the long hand. And there's our short hand. So that is 3 o'clock. Through a vertical line through the center of the clock. So here is a vertical line through the center of the clock. So that's what I'm going to reflect it about. And it looks like my pins are dying. Either that or my ruler is not letting me get to it really well. What is the time after this? So I'm going to reflect it about this. Well, the long hand is going to stay the same. The short hand will move to be 9 o'clock. So this one stays the same. All right. Now, if I take the same time so long hand and shorthand, which it's really kind of funny that I'm doing this because it actually is about 3:15 here, which makes it kind of funny. I want to rotate this. Now I want to rotate this clockwise 90 degrees. So that means that the long hand now is going to be at 3 o'clock and the short hand is going to be at the 6. So what time is that I get? That makes it 6:15, and up at the above the previous example it was 9 o'clock. Right? Okay. Plot the points -2, -1, and -3, -4. So if I'm going to plot them down here on the new graph, so -2, -1 is C, and -3, -4 is D. Okay, so plot them. Now, draw the line segment that connects them. Now rotate the line segment 180 degrees counterclockwise about the origin. Okay, so I want to take those points and I want to rotate them 180 degrees. So if I rotate them 90 degrees, that's going to put me here, right? Yes, 90 degrees puts me here. And another 90 degrees puts me here. Looking for my other color. So it puts me here. And so this one, so that was C, so this is C prime now. And to get to D prime, I go down 3 and over 1. So I'm going to go up 3, 1, 2, 3, and over 1. So this is D prime. And so that's with the new rotation. So C prime is 2, 1, and D prime is 3, 4. Okay. Notice what this is actually doing is it's changing the signs on our points because it's 100 degrees rotation. If it were 90 degrees clockwise, it would put it into the fourth quadrant. Remember, this is the first, the second, the third, and this is the fourth. Okay, so if I rotate it 90 degrees, it puts me in the fourth quadrant. If I rotate it 90 degrees clockwise, I get in the fourth. Counterclockwise, I get in the second. The image will be negative A, negative B. If I rotate the point AB 180 degrees, it will be negative A, negative B. All right. Describe all the, so if I have this figure, describe all the rotation and reflection symmetries. Well, this is a hexagon, so each, I have 1, 2, 3, 4, 5, 6, so this is 60 degrees, 60 degrees, 60 degrees, 60 degrees, 60 degrees, 60 degrees. Now, I know that this image didn't come out to be as perfect as the one on the picture. So notice that if I turn it 60 degrees, I get the same image. Okay, imagine putting a so imagine putting this. I can rotate it 60 degrees, and notice I'm always getting the same picture, no matter how much I rotate it. So I can do 60 degrees, I can do 120, I can do 180, 240, 300. And those are all the rotational symmetries I have. Notice that if I fold this in half, I never get the same thing. Okay, there's no way that I can fold this and ever get the same image because of these little pieces out here on the end. So there's no reflections on this one. There's only rotational symmetries on this one. Okay. Describe each unit and means by which the repeated patterns in the figure. And I don't think I have another picture of this one. If I look at this one, I'm going to go back to my paper, back to my paper here. If I look at this one, I can look at this as a rhombus right here. And that rhombus is rotated, and I take the point right in here. That rhombus is rotated. Then notice I get the same rhombus down here. Okay. I can also take these hexagons and I can rotate them about any of these points, and I still get the hexagon. If I take that point as being in the center of the rhombus, I still get that point if I rotate it 180 degrees. The hexagons are also translated. So if I look at this hexagon and I translate it down, it's a translation, and down and down. The distance of the arrow is how I'm translating it down. You can rotate the figure 180 degrees about the diagonals of the rhombus. And so those are two of them. There's probably a lot more. You can also look at this from the stars. The stars are translated. They're glide reflections. The stars are also, if I look at this, this is the piece I'm looking at. Okay, I can look at this star as being a glide translation. It's also a reflection. Okay, so there's many ways to look at this. Now, if you wanted to go buy yourself some of this transparency paper, it's pennies a sheet, maybe 25 cents, 30 cents a sheet. You can buy a whole box of it for under $5, but a box is like 80 sheets, and so if you bought a box, you could just share them with your classmates. Now, describe by means which the following pattern is repeated. If I draw a line through here, right there, that piece of the figure is translated over and over again. You can also rotate this piece 180 degrees and you get the same figure. There's also vertical lines, like there is another vertical line of symmetry down the center. If I fold this in half along the green line, I get a line of symmetry or a line of reflection. Okay, so there's several there. Now, all right, are there symmetries in the properties of the trees? Yes, the symmetries follow the properties of the trees. So, since a parallelogram has all the properties of the trapezoid, there's a symmetry there. The same with rectangle and parallelogram, since they build on each other. Now, the last two questions on the page. Give instructions as though you're talking on the phone of how to make this. Now, in the notes, there are very detailed instructions. So, and it says to use symmetry. So the first thing I would do is make the big square. So make a square. Then, I'm trying to think of how to do this, how to explain this. Make a tic-tac-toe board. So that means cut the big square into thirds. Okay, so if I make a big square, let's see if I can, that pen does not want to write. Those pens have had their better days. So if I make a square, okay, so I'm following the directions on the notes, okay? That's what I'm going to do, is I'm going to just go through this and follow the directions on the notes. So there's something that looks like a square, okay? Now I'm going to make a tic-tac-toe board, so I'm going to cut it into thirds. And I'm not being very precise about my drawing. I'm just wanting to give you an idea. Okay, so I've got my vertical and horizontal thirds. Now I have 9 squares, so it says shade the center square. There it's shaded. Now, shade the lower 2 triangles. So that means I'm going to cut these 2 into triangles. So cut these in half. Okay, and now I'm going to shade the one closest to the shaded region. All right. And then I'm going to cut this rectangle in half, and I'm not sure if this is exactly. So she cut this, she shaded this, and then rotated it 90 degrees about the corners to get you the others. Now divide the middle top square in half, and in half the top, the next piece, and then shade this, and then rotate it 90 degrees. So you're dividing this in half. And then you're going to rotate it another 90 degrees and get your last piece. And there's your figure. Okay. So fairly good directions. So what I would do is I would draw your directions out and then make sure that you can do it. Give it to your friend and make sure that they can do it. Post it on Facebook and see if somebody else can do it is another option if you're in my class. So again, we're going to draw our square. And I guess for me, I see these fairly easily because actually this star one that we're getting ready to do, the star, it's called the Ohio Star, and it's a quilt block, and I've actually made a quilt using it. I'm about to start on another quilt that uses it too. Okay, and then what you do is you cut each of these in half. And I haven't drawn my lines correct because if they are correct, all of these lines should mix up. So then you color your center, which should be a square, which I've drawn poorly. And so there gives you an idea of how to draw it. That is the end of 9. No, it's not. Hello. We have 2 more questions, and these are repeats from Chapter 5 because these are questions that we use that are reflections and rotations using your compass and your straight edge. And so I'm going to get out my compass, and I'm actually going to get a better straight edge out just because that one was not giving me good straight lines. Alrighty. So, to do a reflection about the line L, so I want to reflect this around L. And so again, I'm going to do these without, I'm going to follow the directions, but you're not going to be able to see the directions. The first thing you do is you pick a point on line L. So there's my P, my point P. You take your compass, make sure your lead is out, and I'm going to measure from P to B. I'm going to draw an arc that goes through. I'm going to do the same thing from A and the same thing from C. Okay, so there are my 3 arcs. I call this point B1, this one A1, and this point C1. I'm going to take my compass and I measure from B1 to B. I flip it around to the other side of L and I make a mark. I measure from A1 to A. I flip it around and mark on the A arc. I measure from C1 to C. Flip it around, mark across the C arc. Use my straight edge to connect those points. So this is B prime, A prime, and C prime. Okay, there's my reflection. Now I'm going to do my rotation. The first thing I'm going to do is I'm going to extend out my rays. Call this point O the origin. I measure from O to B, and I draw a circle around B using OB. Go to C, draw a circle, and I think I got off a little bit. Having to go around the camera, I got off a little bit, but that's okay. Go to A, draw a circle, and I'm not going to go all the way around just because I'm having a very hard time turning my paper. So there are my 3 circles. I take my compass, I measure from one ray to the other ray on the B. This tells me the angle. This is the measure of angle alpha for the B. Go to B, draw the point. That is how much counterclockwise I need to draw B. I'm going counterclockwise, so I'm going this direction. So this is now B prime. Go to the C, measure, go to C, copy, go on the A circle, measure, go to A, copy. So this is C prime, this is A prime. Connect my points. And there's my rotation. All right, this now concludes 9-2, and so we will start 9-3 in the next video. So there's the last of the rotation. This concludes 9-2. We'll start 9-3 in the next video. If you have any questions, please email.